Hi dear friends, welcome to our online classes. This is yours Alam Sai Krishna. In this session, we have to discuss the chapter about electric current. It is one of the most important chapters of the physics. Maybe we can expect one or two questions for every competitive examination, maybe central government examinations, maybe state government examinations like TSPSC, APPSC and some other examinations. Yes, here maybe we can carry one or two questions are compulsory. Okay, electric current. What is meant by electric current? Yes, it is also nothing but form of energy. Like light also form of energy, heat also form of energy, sound also form of energy. Like electric current also nothing but what form of energy? Form of energy. This energy is formed due to the charges. This energy is formed due to the charges. Due to charges. Due to charges. Here charge is representing with small q letter. Q that is equal to Ne. Here N indicates number of, E indicates electrons. N indicates number of, E indicates electrons. Yes. Here E electron charge is a negative charge. What is the value of the charge? Minus 1.602 into 10 to the power of minus 19 coulombs. Yes, minus 19 coulombs. What is the charge of this electron? Minus 1.602 into 10 to the power of minus 19 coulombs. That we have to try to keep in the mind. About this electricity, about this electric current, first time the research was done by William Gilbert. Yes, he is the scientist William Gilbert. He was done the research. He was done the research as first time about electricity. Yes, and just we got about the charge. The charge is classified into two types. The charge is classified into two types. Charge is classified into two types. Yes, who was classified the charge into two types? Benjamin Franklin. Benjamin Franklin is one of the scientists. He classified the charge into two types. What are those? Homogeneous, heterogeneous. Homogeneous and heterogeneous. Heterogeneous. Yes, the charges are classified into how many types? Two types. What are those? Homogeneous charges and heterogeneous charges. Homogeneous means similar charges. Heterogeneous mean different charges. Homogeneous is positive, otherwise negative. This is homogeneous. Heterogeneous mean positive, positive. Yes, homogeneous mean positive. Yes, negative. Heterogeneous mean positive, positive. Here, what kind of the forces are work while the homogeneous is here? Repulsion forces will work. Which forces will work? Repulsion forces are working between of the homogeneous. Is heterogeneous, here the attraction forces are work. Attraction forces are work. Is here the work, the forces are attraction force. Here the work, the forces are repulsion forces. In between of the two positive charges, otherwise in between of the two negative charges, which type of the forces are work? Repulsion forces are working. In between of the opposite charges, maybe plus so minus, maybe minus plus so, attraction forces are working. Attraction forces are working. Homogeneous, heterogeneous. That we have to keep in the mind. Here, for example, there is one soap bubble is there. For this soap bubble, if I give the all positive charges, positive, like that. If I give the all positive charges to these soap bubbles, what will happen? When we give the positive charges to the soap bubbles in between of the positive charges, repulsion forces will work. What should be work? Repulsion forces will work. Yes, in between of the all positive charges, what should be work? Repulsion forces will work. Repulsion forces work. Due to the working of the repulsion forces in between of the molecule, in between of the positive charges, what will happen? The soap bubble size will be increasing. So bubble size will be increasing as a gradually is again working, again working, again working. After some time, the soap bubble will break. So bubble will break due to the working of the repulsion forces in between of the same molecules. That we have to try to keep in the mind. Again, if we give the charge to this type of the materials, if we give the charge to this type of the material, shape of this type of the materials, is at the time the charge will be stored at these places. Charge will be stored at these places like these. Like shape of the materials, if we give the charge, what will happen? It should be stored at these places only. As here you have to see the charge is locating at these places only. As due to locating the charge at these places, it is protecting from the thunders. It is protecting from the thunders. The person who are sitting in the car is at the time the surface area is protecting from the thunders only. That we have to try to keep in the mind. Here also, as usual, if we give the charge to like this type of the material, the charge will be located at the corners. Charge will be located at the corners only. Like this, it should be locating at the corners only. Is due to the locating the charge which we gave at corner place, it helps to protecting from thunders. It helps from protecting from thunders. It helps from when we give the charge, it is locating in these corner places. It is helping from thunders. That is also one of the most important. We gave for the soap bubbles, we gave for the car, and we gave to the like these materials. These all those things also protecting from the thunders only. Then next, for example, it is our earth. It is our earth. It have the infinity number of the positive charges and infinity number of the negative charges. This earth also have the infinity number of the positive charges, infinity number of the negative charges are present. Is that's way this earth also we have to consider as a electrical sink. That we have to consider as a what? Electrical sink. That we have to consider as a electrical sink. That we have to consider as a electrical sink. Because of what amount of we require the charge, it is have the capability to give. If we give the lot of amount of the charge to the earth, it have the capacity to gain also. It have the capacity to give, it have the capacity to gain. Large amount of the charge, maybe it should be gained if we give to the earth. Otherwise, if we require, it should be give to us. That's why this earth we have to consider as a electrical sink. Earth we have to consider as a what? Electrical sink. Electrical sink. This earth we have to consider as a what? Electrical sink. That we have to keep in the mind. See, we are transferring the energy. It's taking. Maybe if we require, it should be give also. As here also. As typical conductor system. As maybe if we give, that will be take. Otherwise, if you require, that should be give. Yes, and due to having of the large amount of the positive charges, large amount of the negative charges in the earth, it should be work as a electrically neutral. It should work as a how? Electrically neutral. Electrically neutral. That we have to try to keep in the mind. Then next, most important concept, types of electricity. Electricity is classified into two types. What are those? Static electricity, current electricity. Electricity is classified into two types. What are those? Static electricity and current electricity. Yes. Sir, what is the difference in between of the static electricity and current electricity? How can define the static electricity? How can define the current electricity? Sir, what is the uses with the current electricity? What is the uses with the static electricity? Let us see. Yes, first one, static electricity. Static electricity. This static electricity is formed due to immobile charge. Due to immobile charge. Immobile mean not moving. Immobile mean not moving. Immobile charge mean not moving. Yes. The static electricity is formed due to immobile charge, which is present on the surface area. Which is present on the surface area. Static electricity is formed due to immobile charge. Immobile means not moving, not moving. It should be present on only surface area only. It should be present on only surface area only. It should not be moved. Due to that type of the charge, formed electricity is nothing but static electricity. Yes. Sir, where we are using this static electricity? Sir, we are using this static electricity in the Xerox machine for the purpose of the Xerox only. Yes, in the Xerox machine, the charge, the current which is present is here. This is nothing but what? Static electricity. Yes, in the examination, if they ask the question as directly, what purpose we are using the static electricity? For the Xerox purpose, we are using the static electricity. That we have to try to keep in the mind. Yes, then next one, current electricity. Yes, before define the current electricity, we have to take one conductor. Conductor means simply which it can pass the electric current through them. Which it can pass the electric current through them, that we have to consider as a conductor. Okay, this is one of the conductor you have to take. Any one of the conductor you have to take. This is the cross-sectional area of this conductor. Cross-sectional area of the conductor. Okay. It is the cross-sectional area of the conductor. Yes, in the conductor, what should be move? Electron should move. What should move? Electron should move. Yes, electron should move. Yes, what should move? Electron should move. Yes, how can we define it? How many number of electrons are crossing the cross-sectional area in 1 second? How many number of electrons are crossing the cross-sectional area in 1 second? We have to consider as a current electricity. Yes, simply number of electrons crossing cross-sectional area in 1 second. In 1 second, number of electrons are crossing the cross-sectional area in 1 second. Yes, in 1 second, how many number of electrons are crossing this cross-sectional area? That we have to consider as a current electricity, otherwise electrical current. Yes, see here, so many electrons are here, but some of the electrons only crossing the cross-sectional area. It means simply how I am defining number of electrons crossing the cross-sectional area in 1 second. Number of electrons crossing the cross-sectional area in 1 second is known as a current electricity, otherwise electric current. This we have to represent with the symbol is I. This we have to represent with the symbol is I. I that is equal to Q by T. I that is called what? Q by T. I that is called what? Q by T. I is nothing but electric current, nothing but current electricity. Q is nothing but what? Charge. Q is nothing but charge. T is nothing but what? Time. T is nothing but what? Time. I is equal to Q by T, which means I is equal to charge by time. Here units, while we write I is equal to charge mean coulombs. Coulombs, time, seconds. Yes, in that way also correct. I is equal to Q by T is correct. I is equal to charge. I is equal to charge by time also correct. Otherwise, I is equal to coulombs per second also correct. coulombs for second also correct. Here is electric current units we have to consider as a ampere. What is that? Ampere. Electric current units are nothing but what? Ampere only. Yes, amperes are represented with the symbol is A. Amperes are represented with the symbol is A. Electric current units are nothing but what? Ampere. That we have to represent with the capital A only. Which A? Capital A only. Yes, this electric current we have to measure by using ammeter. What is that? Ammeter we have to use. Ammeter we have to use. By the using of the ammeter, we can measure the electric current in the circuit, electric current in the conductor. Yes, here ammeter should be connecting in the series manner. Ammeter is connected in which manner? Series manner. Most important concept. Units of electric current. That electric current measured by using of the which meter, and that ammeter should be connected in which manner? In the series manner. Previous competitive examination question is that. Yes, we got that complete information about the current, electricity, nothing but electric current only. Yes, here now this current, electricity, nothing but electric current. It's again classified into two types. Classified into how many types? Two types. What are those? This again classified into AC and DC. Sir, AC mean, DC mean, DC indicates direct current. AC indicates alternate current. DC indicate direct current, AC indicate alternate current. DC mean does not change its direction. It should always move in same direction. Does not change its direction. Does not change its direction. Does not change its direction. Always move in same direction only. Yes, that is nothing but what? DC. Yes, does change the direction in every second. In every second it should be changed its direction from positive to negative and negative to positive. In every second. In every second it should change its direction. Yes, direct current does not change its direction. Alternate current, in every second it should be change its direction. How it is changing the direction? Always from positive to negative, otherwise negative to positive. In every second it is changing the direction from positive to negative, negative to positive only it is changing. Yes, that we have to keep in the mind. Yes, sir, where we can get this DC current? We can get from the cells. We can get from the cells only. This DC current we should get from the cells only. This DC current we have to use in the TV, computer. A small electrical equipment purpose we have to use this DC and computer. Otherwise, in our mobile phone we are feeling the current is which current we are feeling? We are feeling the DC current only we are feeling. Always we are using the charger to fill the current in our smartphone, otherwise mobile phone. Yes, which current is converting into which current is here? Here alternate current is converting into the direct current only. Without charger, just you have to try to keep the two wires in the plug and insert the slot into your mobile phone. A fraction of seconds it should be blast. It should be damaged because of no need to supply the alternate current as directly into your mobile phone. It should not be work. That's why we are charger using. The charger here. Yes, this is 2 pins are there. No. Yes, AC current it should be converting into DC current. Yes, AC current converting into DC current. As in the mobile phones we are feeling current is DC current. The TVs and computers, the you utilizing current is which current? DC current. Alternate current is converting into DC current only. As where from we can get the DC current? I told you people from the cell only. From the cells we can get. As for the small various of the electronic device working purpose which required. So there is no availability of the DC current. As you have to convert it like the charger we are using now, like that AC is converting into DC only. Yes, here AC current. What purpose we are using the AC current? What are the applications with this AC current in our houses? In our houses we are using current is AC current. In our agriculture purpose we are using current is AC current. For the industries we are using current is AC current. For rail we are using current is AC current. Houses also AC, agriculture also AC, industries also AC, rails also AC. A smartphone for DC. Yes, that we have to keep in the mind. Small difference is there. Alternate direction changing. Direct not changing its direction. Yes. Then here most important, AC current convert into DC by charger. The process is known as a charging. The process is known as a what? Charging. As DC to AC, that we have to know as the inverter. Yes. Most important, there is a possible to ask the question in the examination. AC to DC charger, DC to AC is inverter. Have any doubt? No doubt at all.